Hi, welcome. A warm welcome to you. In this video, we will see about in triangle inequality. We will see about the sum of two sides of a triangle is greater than the third side. How to understand the concept and how to do the proof mathematically and also do some problems based on that. First, let us try to understand it by intuition, actually, without going through the mathematical proof. See with a little bit of practical geometry and common sense to see how this makes sense. Let me say that let us try to construct a triangle with the sides of 12, comma 6, comma 4. Let us say that I have taken this as A, B, and this is BC, and this is AC. I'm thinking actually, right? I'm not sure whether they will meet or not. What I will do then is I'll just put AB here because I'm not sure whether they will meet or not. What we want to check is, given these three sides, we want to see, try to draw this triangle and see, find out when we can form a triangle with the given sides, whether it is feasible to create a triangle, whether they will form a triangle or they will not form a triangle. So for that, what I will do is I'll try to take here A and B. This is a straight line, and I say that it's equal to, that's a straight line, and I say it's equal to AB, and it is 12, right? Now, how will you draw the triangle? You will take the compass, and from here, next you have to go for 6, right? So out of 12, middle is 6. That means I will take the compass for 6, and I will try to draw the arc. I will try to draw the arc like this. I have drawn the arc from here. I have drawn the arc for 6, right? Now, similarly, from B, I have to go for 4. This is 6, so this is 4. I have taken the compass and I have drawn the arc here. You can see that these two arcs are not arcs are not intersecting. That means you cannot form the triangle. To form the triangle, these two arcs need to intersect, then only the third side will come. So see here, if this is 6, this is 4, I cannot form a triangle. Now let's take another example and say that suppose the sides are 12, comma 6, comma 6. Now also I will do the same thing. I will take AB as 12. I will take AB as 12. Then next from A I have to go to the midpoint. Let us say he is here. That is 6. So from here I'll draw the arc so that I see from B I can intersect. So this is the center and this is the radius. I will draw the arc. The arc somehow looks like this. Similarly from B also it is 6. So I will also draw the arc from here, and I see that they are both intersecting. That means they are not forming the triangle, but they are all becoming part of the same line. The C is here. They are not forming the triangle. We seems to be reaching a logic here. If I look at the first sides 12, 6 and 4, I see they are not touching. So I cannot form a triangle. But in the second case, I see that they are touching each other, but they are not forming the triangle. Actually, they are making a straight line. So what I will do now, as a third case, I will take examples of, I will say 12, comma 8, comma 8. Let us take this example and see what happens now. I will draw another straight line. I will draw another straight line, A, B. Remember this is your midpoint 6, C. let us say, not C actually, that's a midpoint which is of 6 because this total length is 12, so that is 6. Now from A I have to go for next side, that is 8. That means I'll draw the circle like this. I'll draw the arc actually. I'll draw the arc like this. Similarly, from B I have to go for 8. That means this is 8, let me say. I will draw another arc. I will draw another arc, and I see that it's intersecting. That means we are able to form the triangle. From these three, can we understand something? If you see in the first case, where you have 12, 6 and 4, you are unable to create the triangle. In the second case, where the remaining two sides are sum is equal to the first side, you are forming a straight line, but you are not forming a triangle. But in the third scenario, you see that you are able to form the triangle. So, if you just try to understand this, the 12 is AB, and next you are going for 8. That means you are coming here, and from B you are coming here. This total length, if you add them up, that is greater than AB. So the point is, the triangle will form only if AC plus BC is greater than AB. If we want to generalize this, we can apply for, say that any two sides sum should be greater than the third side, then only you can form the triangle. If you see here, two sides are 6 and 6. They are not greater than 12. That's why the triangle is not possible here. If I go little bit before, 6 plus 4, 10 is not greater than 12. That's why the triangle is not possible here. So this is how you will come back to this theorem or corollary, which says that the sum of two sides of a triangle is greater than the third side. This is what we have proven by, we have understood and we have proven with the help of practical geometry and some common sense. But how I can prove it mathematically? By leveraging whatever the triangle properties we have. So let's go ahead and do that and try to solve it quickly. So for that, I'll just try to erase this part so that I can do the proof for you. So you understood now that in the last scenario where we have 12, 8 and 8, 8 plus 8 is equal to 16, which is greater than 12, or if you see from practical geometry perspective, you are crossing the midpoint and going to the other side from A and B. So they are forming an arc which is intersecting, which is very interesting and which tells us that the sum of two sides of a triangle is greater than the third side. Now here we have two sides. We have two sides AB and AC. We want to prove that AB plus AC is greater than BC. This is what we want to prove. Okay, whatever we have proven just now with intuition. So for that, what I will do is I will try to draw this. See here, I have to prove AB plus AC greater than BC. That means I should have both on. See, if I want to prove this AB plus AC greater than BC, somehow I should be able to. First, I will get into angles only. Then based on that only I will come here. If I come to AB plus AC, that means I should have both of them on the same line. Then only I can go to the angle. So what I will do, I will take this AC as it is and I will extend from here. I'll extend from here a length till I go to D such that AC equal to AD. I say AC equal to AD and I join them. Let us say it's a straight line for a second, or let me just change it. Let me just take this direction so that I'll get it. Okay, right. Now you can see here what I did is I have to prove AB plus AC greater than BC. Now I know that the proof will go with angles, then only I will say that the side opposite to the angle is greater, that's why AB plus AC. So I should have AB and AC on one side. I cannot put AC on that side. So what I did is I extended A so that AC equal to AD and I found a point D. Now our focus is on this triangle, that is triangle BCD. Now since this is isosceles triangle, immediately you can say that this angle is equal to this angle, or angle ADC is equal to angle ACD. So that will be my first statement, which says that angle ACD is equal to angle ADC. Remember that we have to prove the sides. That means we have to start from angles, and we should have angles and sides opposite to them so that we can prove it. Right. Now ACD is equal to ADC. This is perfectly fine because it's an isosceles triangle. Now AB plus AD opposite side is BCD. That means I have to add this part also. I have to add this part also so that I can say BCD. So what I will do, I will say ACD plus angle ACB is greater than angle ADC. But this ACD plus ACB is nothing but equal to BCD. So I will say this is nothing but angle BCD is greater than angle ADC. But I also know that angle BCD is greater than angle ADC. Angle ADC is nothing but equal to angle BDC. So I will say angle BDC. But if you look there, BCD, angle BCD opposite is BD. So this gives me angle BCD opposite side is BD. So I know from the theorem that if the side is angle is greater, then the side opposite to is greater. Opposite to it is greater. So BCD opposite is BD, which will be greater than angle BDC opposite side is BC. So BD will be greater than BC. But you know BD is nothing but equal to BA plus AD, and you know AD equal to AC because it's a isosceles triangle. That's how you can prove BA plus AD greater than BC. That is nothing but equal to BA plus AC greater than BC. Let me explain that again. We have taken A, extended it such that AC equal to AD. It's isosceles triangle now. So ACD equal to ADC. Now I have to prove that BA plus AC is greater than BC. That means BA plus AC is AD. So I should have this total angle opposite. So what I did, I added that angle. I said that angle ACD plus angle ACB nothing but equal to angle BCD, which is greater than angle ADC, but ADC is also equal to BDC. So that gave me BCD greater than BDC, but BCD is nothing but opposite side of BCD is nothing but BD. BD is greater than BC, but BD is nothing but equal to BA plus AD. You know that AC equal to AD because that is the construction we have done. So that gives me AB or BA plus AC greater than BC. So from this we have looked at the proof mathematically and also by intuition using practical geometry to say that you can form a triangle if you are given three sides. The triangle is possible only and only if any two sides of a triangle is greater than the third side. So let's look at couple of examples now. Let us see whether the triangles are possible here. Let us say that the sides are 14.8 and 7.6 and 8.0. Now let us say this is A, B, this is BC, and this is CA. Now what I should do first? I should check for AB plus AC, AB plus BC greater than CA. What is AB plus BC? 14.8 plus 7.6. 14.8 plus 7.6 is greater than 8.0. This is nothing but 22.4, which is greater than 8.0. So this is perfectly fine. Now let's move to the next one. BC plus CA should be greater than AB. BC is 7.6, CA is 8.0. They should be greater than AB, that is 14.8. Let us check this. If I add this is 15.6, which is greater than 14.8. So this is also is fine. Let's look at the third condition. The third condition is CA plus AB should be greater than BC. CA is 8.0 plus AB is 14.8 greater than BC, that is 7.6. So this is 22.8, which is greater than 7.6. So you can form the triangle because it has proven that any two sides, sum of them is greater than the third side. So you can form a triangle with this. You can form a triangle with this. Let's take another example and see. Let us take a simple example so that we can do the calculation easily. Let us say the sides are 10, comma, 6, comma, 5. Now let us say this is AB, let us say this is BC, and let us say this is CA. I will write down here. First I should have AB plus BC greater than CA, BC plus CA greater than AB, CA plus AB greater than BC. First let's look here. AB plus BC, 10 plus 6, 16 is greater than 5. Perfect. Let's look at the next one. BC plus CA, 6 plus 5, 11 is greater than AB, 10. Perfect. CA plus AB, that is 5 plus CA plus AB greater than BC, which gives me CA equal to 5 plus AB 15, which is greater than 6. So you can form the triangle. Now let us say, suppose this value of 5 is changed to 4. What happens now? 16 is greater than 4 is fine. 10 is greater than 10. This becomes 4. This is fine. 6 plus 4 becomes 10. 10 is not greater than 10. So in this case, you cannot form the triangle. Now, let's also look at one interesting point here is that if you have been given two sides and asked to find out the range in which the third side should be, how will you do this problem? Suppose I have been given that the two sides are 12, comma 5. Now what is the third side range. That means between which values the third side should be. So for that, the way we have to approach this is the value should be between 12 plus 5 and 12 minus 5. That means the value should be between 17 and 7. That means the value can be 8 or 9 or 10 or 11 or 12 or 13 or 14 or 15 or 16. You can cross check for any of these values the condition that to sum of two sides of a triangle is greater than the third side will apply. If the values are less than 8 or the values are more than 16, then this will not be applicable. So how you have to do is, if you have been given two sides, sum them up, also subtract them. The value should be between this and this, excluding the boundaries. That means boundaries are not included. So you have 8 to 16. Let's take an example. Let us say suppose the value is 6. Now 5 plus 6 11 is not greater than 12, so it's not possible. Let us take 12. 17 is greater than 12. 24 is greater than 5, and also 17 is greater than 12. 24 is greater than 5. After that 17 is greater than again 12. So you can see that you can form that. This is interesting. Just remember that whenever you have been asked to find out the third side range, it should be between the addition of them and between the subtraction of them, excluding the boundary values. That means 17 and 7 will not come. Remaining all will come into picture. This is about the interesting topic which covers about, suppose you, can I form a triangle if I have been given three lengths, three sides? Is it possible or not? Depends upon this particular point that sum of two sides of a triangle should be greater than the third side. And we have also seen couple of examples with respect to that. So that's it for this session. Thanks for visiting. Bye for now. We'll continue the geometry.